Hey, have you ever hitched a ride on a train going nowhere and thinking you're going somewhere? Let me show you an example of these ball-believing space fanboys and the hypocrisy and the lies and their bluffing. This is great. I just gotta show this to you guys. So you should be seeing my screen here. Okay, I made a post. Maybe you guys saw the video. I was explaining to Michael Toon how I thought that the sun would easily do what it does when it sets over a flat earth, right? So there's a lot of comments and stuff. We're going to go a little bit down here. There's a couple comments that are priceless, and we're going to compare right now in this live stream. I'm going to compare NASA's, this is what, we're going to look at an image that someone gave me the link to so that they could prove that, my video was out of focus, but that has nothing to do with the sun. The conversation kind of changed. So they were saying, why would the sun not appear to get smaller as it goes away? And so I said, why does the sun appear to shrink, or why doesn't the sun appear to shrink if this was the case? Probably the same reason Starlink and ISS don't appear to shrink as they go off over the horizon. I don't know that reason, but it does appear that way. So I gave him a video that I took of the space station. And I'll just show you this full screen for a minute. So you can watch the ISS go over your head and go, it doesn't really change angular size the whole time. You see it, off at the horizon, then it's going over your head, and then you see it off at the other horizon. It doesn't really change size. So I was just sent that video in there. So then I guess it's Greg Harridge said, we can stand on the beach. Maybe I need to go farther down here. Okay. Let's see. I guess I got to open this up so we can see what he says. We can stand on a beach on the west coast and watch the sun disappear over the ocean. There are no obstructions of the sort that you mentioned between us and the sun, yet it disappears. Why? You also have to explain. Isn't that funny how they always say that? You have to explain this. Why the angular size of the sun doesn't change. If it was small and local, the distances that we know the sun travels would cause it to shrink, but it doesn't. And I try to like these comments, even if I disagree with them, because it's a good conversation. Do you know what I mean? I'm not going to, laugh at it or something, unless it's funny, then I will. So I said, I don't think the sun is small and local. I think it is celestial and not in a place with physics as we have on the earth. There are waves between you and the sun if the sun goes behind the waves, which is a simple concept, I think. Because excuse me, let me explain. As anything is going away from you that's over your head, it appears to go down. Down, down, down. Hey, TrueTube. Thanks for the video yesterday. That was some good stuff you were saying. And Davey313, welcome. Aloha. So I said, there are waves between you and the sun if the sun goes behind the waves, which is a simple concept, I think. As something above you is moving away from you, it appears to go down and down and down and down and down. It doesn't suddenly decide to maintain its apparent position just so you can continue to see it. There will be waves closer to you that will eventually cover it. What are your thoughts on why the ISS and Starlink don't shrink in angular size as they disappear off into the distance? And I said, I'm not in agreement with all the flat earthers. I believe that orbital velocity is just the path of the stars, which is a circle turning around Polaris. This star, so if you guys aren't familiar with this video, I'll just hit play here really quick and we'll go watch it. I made a video that was a NASA challenge, I think I called it. We'll look at the description here once it starts. My computer's a little slow. This is hilarious, you guys. Just wait till you see what we're trying to compare to here. So this is a shot that I took of Polaris a couple years ago. And actually, look at that. It's almost exactly 2 years ago, August 21st. So just over 2 years ago. So here's what I said in the description. Actually, let me pause it so my computer's really slow. Okay, seriously, I want to point out that this is focused very well. It is very difficult to get the bright Polaris and the tiny star, which is Polaris AB, to show up together on film. I want to see NASA cough up something because this star is beautiful and the children should be seeing it instead of nothing. And what amazes me is that NASA doesn't even have a video of Polaris available. They don't even take a video of Polaris, which you'll see in the Facebook post here, which this guy proves to us. So I wrote, meaning that there's no zero G from falling around a globe toward the center of it, rather that there's no physics in that place of darkness where the sun, moon, and stars are, and planets. So then he says, the reason why the sun appears to go down as it gets further away, blah, 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 is because the Earth is a sphere, and the curvature of the Earth is what's getting in the way, not waves, trees, cities, or mountains, which is hilarious. It's such puny thinking. It's like puny brain, like the size of a pea. That's what you think if your brain is the size of a pea. You need to expand your ways of thinking. There's other explanations for this stuff. I'm not sure what you mean by the ISS not changing in angular size. Well, exactly what I said. It doesn't change in angular size. So I said, LOL. The only problem with that reasoning is that the surface of the Earth is observably not curving away. And then so he says every single observation shows curvature. You think the sun is a celestial body, but not in a place with physics as we have on the Earth. Do you know who Edmund Halley was and the predictions that he made using physics? No, he made predictions using history. So that's actually false, Greg. What you're saying there, it's totally false. He didn't use any physics to figure out Halley's Comet, not at all. So then Michael Toon was commenting on the sun thing again, but we'll stick to Gordon McAllister now, Mulcaster, sorry. So he says, let's see, is that okay? That's maybe not the right guy. Maybe I got to go farther. Oh, okay, here we go. Joe Hill, your out of focus video of a star is not particularly interesting. Try buying a telescope, he tells me. Have you guys seen that I have some nice telescopes? And that's how I get these videos? See, what Gordon doesn't realize is that I'm zoomed in on this star much further than he thinks. So he thinks that it's out of focus when that's actually the details of the colors of the star. You can actually see the star. So then he says, the only problem with that reasoning, blah, blah, blah. They always do that. They always tell you what you said, and then they're going to try to tell you about it, which is your denial of observed reality combined with your lack of understanding of geometry and your unwillingness to do any math does not make a compelling argument. It just makes you look foolish. And then I said, I love hearing about how my video of Polaris is not in focus. That video is not out of focus, and it was taken through an 8-inch Dobsonian reflector with a 4-foot focal length. It may be a better idea to show me your video that is in focus. LOLZ. I have many telescopes and obviously better optics than you do, or else you would just show me your video. Put your money where your mouth is. I will be waiting. So then he tells me what I said again. That video is not out of focus. Yes, it is. It's just proof that you can improperly use any equipment if you try hard enough. Okay, so now he knows that I have a telescope that I got the image through, so he's got to say, oh, it just shows that you don't know how to use it. And then he says, it may be a better idea to show me yours that is in focus. Now here's where it gets good, guys. He writes, will you settle for a still image? That's the whole reason why I put that NASA challenge out, is because NASA only gives you a still image. And wait till you see this still image, guys. We're going to look at it right now. Okay, this is what he sent me. Now, okay, you see Polaris AB right there. It's kind of on the bottom. It's like it's at like 3 o'clock or 4. I mean, 4 or 5 o'clock, right, from where Polaris is. So this is what we get from NASA, from Hubble Space Telescope. Now just wait, guys. You might want to sit down for this, because see on my cursor there's that little plus sign. Yeah, we're gonna look at this a little bit closer, and you'll get to see what NASA provides you. Still image. There you go, guys. Isn't that impressive? Whoops, let me move this over. Look at that. Let's count the pixels, why don't we? Polaris is about what? 1, 2, 3, 4, 5, 6, 7. About 10 pixels wide. Their blurry Polaris is about 10 pixels wide. Wow. And Polaris AB, can't really even tell that it's a star, can you? That's what he gives me. Okay, let's go back here. Hey, Michael Kahn, you're in on this conversation too. And we're not trying to rip on these people because, we don't need to call them small-minded fools. We need to convince them that they're believing pseudoscience garbage. And if that's what Hubble gets you, why did we pay for Hubble? Tell me. Yeah, Flat Earth Space Agency says intense. Yeah, it's intense because you don't know how many times I've dealt with this. Your image is out of focus. Okay, so I wrote, let me show you something you have no clue about. Look at your crappy still image. Notice how far away Polaris AB is away from Polaris. I'll show you guys again. Do you see the distance there? It's like right next to it, right? It's almost like you can't even tell that it's there. Well, let me show you something. Okay, so the exact video that I gave him that he said was out of focus, you can watch it and you can see Polaris AB way over here. So I've got a video that's focused better. I'll just show you this image, but we're gonna watch the video in a minute. A couple videos. You can barely see it in this image, but if you watch it in the video, you can see that it's there better. So I wrote, you should buy a telescope once. Learn something about on your own instead of believing junk pseudoscience. And Hubble, why did you guys pay for Hubble? Why did we pay for Hubble? Okay, so then I gave him another video. I said, here's another eyepiece. Look at it. Why did we pay money for Hubble again? So I'm just going to show you the still shot. See how far away Polaris AB is from Polaris? Let's go look at NASA's image again. Huh? Do you see that I'm magnified like way further in than they are? With Hubble Space Telescope. Let's just do something for fun. How much for Hubble? I guess I got it right. Okay, how much did it cost? Only $4.7 billion by the time of its launch. $4.7 billion. You guys want to know how much I paid for my telescope? $500 for the Dobsonian reflector. $500. NASA throws money away. They suck. Sorry. So let's go back to the post. So we're going to watch this video, and we're actually going to watch a couple of them. So here's the one, the NASA challenge I put out, and you'll see what I mean when I say that you can see the star better in the video. I'll just play it for a minute here and go full screen. You can see Polaris AB up on the top left there, kind of. Whoops. See how it kind of flickers in and out. It's really hard to get Polaris and Polaris AB to show up with any detail because of the different exposure, the different brightness in exposure or whatever. So you can see there that I'm zoomed in much farther than Hubble. So let's look at another video. Now here's what I did to get this. Once it goes back to the regular screen, oh, I guess this wasn't the one. It was up here. Okay. I typed in effed up world Polaris. Not too tough, right? Let's see here. So it gave us a bunch of my videos. Okay. Oops, go back up to the top. Okay, the North Star, Polaris. Polaris shows the moon. That was a live video I did, I think. Streamed 1 year ago. Let's see what it looks like streamed. I don't even know. This is with my iPhone 6S, guys. And you can see that my iPhone 6S through my Dobsonian, if I remember right, it's about the same magnification as NASA's Hubble still image. Actually, I'm even closer. You see that? Let's go to, I think 720 is all we can get. Yeah, because it's my iPhone 6 and I'm live streaming from my iPhone 6S. It's an old phone. So here's, I got the sound on. Do you see that? Should we compare it to NASA's image? So this star, every 24 hours, this star goes around Polaris.
Tinted monocle.
It goes around Polaris. 24 hours, 24 hours, 24 hours, 24 hours. It circles that star. This is Polaris AB, and this is Polaris. With an iPhone 6S. And it's better than Hubble. And it's a video. Come on, NASA, you suck. You guys can't even get a video. You can't even provide a video. And yeah, I'm definitely going to be putting a link to this live stream right now in that Facebook post. But you know, these guys are bluffing. So this guy obviously has never looked through a telescope, never tried to film anything through a telescope. He doesn't know at all what he's talking about. And the first thing he says is, your out of focus video of Polaris isn't very impressive. Do you guys see where he's missing out on the truth? These stars are beautiful, you guys. So I have tons of videos of Polaris. And the one I chose was, I think this one. Well, actually I have it, or did I have it here? No, I think it was this one. Let's just look at this one. So this is a different eyepiece. And this one is same telescope. It's an 8-inch Dobsonian reflector. Now if we go a little bit further, I think this is the same video. Okay, yeah. You can see that star kind of. Now there's other things we can do to see it better. Okay, you see that? Let me go up here full screen. And this is a video that I took. NASA doesn't even have a video. Yeah, guys, hit the thumbs up. And share this. Share this kind of information. At least share these videos like that NASA challenge. Maybe I'll put a link in the chat in a minute. Okay, so there's something else we can do, though. We can do some live editing, which we're going to do right now. I'm going to turn the brightness up a little bit on this whole image. See that? If we were to measure pixels between those two stars and compare it with, I can't do it without going small screen. Compare it with this garbage. Here's what you get from NASA for $4.7 billion. You get this garbagey pixelated trash. That's what it is. It's trash. There's not that. It's a still image. Now I'm sure NASA has a better image than this. This is just what this dude showed me, you know, because he's such a smart guy. But that's the problem, you guys. That and what I want to make, the point I want to make, and then I'm going to turn this off. The point I want to make is that, we'll get this link in the chat here. Whoops, I hope that's the right link. Okay, let's see. Share this video out that's in the chat right here. Share that out. Put that on your Facebook or something. See if NASA can get an image like this with color. And I actually, it's a terrible shot right now because I still have the editing on. Okay, there we go. That star is green and like a reddish maroon and white. And every time I point my telescope there, that's what it looks like. Now, it depends on how far you're zoomed in or how far you're not. I want to see the high resolution footage. Okay. Oh yeah, this is, I should have this on 2160. Sorry. That makes a difference too. Make sure you're not on 480p. So we're going to go full screen here and then we'll see what it looks like on 2160. Oops. Sorry guys, it's a little slow going. Now, I'll do the color thing again just so you can see a little bit better. Oh, that's the end of the video. So, this is the NASA challenge one. And I hope I'm not... Okay. You can't see the star as good in this video. The Polaris AB. Let me hold on a minute. So there's really no way to know how far someone's zoomed in on a video unless you have something like that Polaris AB star to compare it to. Like in their image here, you can see where Polaris AB is. It's almost touching Polaris, it looks like. So NASA's Hubble image is way out of focus. That's what I say. Do you want to see what it looks like in focus? Here. Let's go right about here. I'll give you a link to this video too. Look at that, 90 views. 90 views. It should have more views than that. That's what I think. Okay, so we're in 4K, 2160. And I just clicked it about halfway into the video. Okay, there's that. I'll show you with the editing on. Okay. I'll put a link for this in the... But really, people need to know this stuff. Let's do this. Let me take a still shot of this. Actually, I'm just going to leave it playing and take a... Or I'll just go like this. There. I just didn't want the YouTube stuff on there. Anthony Dickinson, what's up? Okay, still image. I just took a still screenshot. And then I'm going to go over to NASA's image and we're going to take a still screenshot. Okay, screenshot. And then we'll compare them, okay? So, how do I do that? Let's see. Oh, I know I can do that. Let's see. Okay, here is our still shot. And actually, that was a bad timing for still shot. I have to get a different one. Sorry. Let's go back to this and hit play. It takes me forever because my computer's kind of slow going the full screen thing. Okay, we'll take a few of them just so we got a few to look at. Because it kind of goes in and out of view a little bit. Okay, bunch of still shots, screenshots. Okay, so now, picture. Okay, here's NASA. There's NASA's. And there's mine. Whose is better? Who's more in focus? Mine or NASA? You tell me. If we wanted to get them the same size, we can't because they aren't zoomed in nearly as far as I am. Because actually, if you look at their picture, think how far I'd have to zoom in to get that star away from that other star. This little star here. Oops, are you seeing that? Yeah, you're seeing that. I was thinking you were seeing the video for a second. Okay, so now I'm going to go grab a link. Let's see here. You tell me, who's got the better telescope? Hubble or Joe Hill? Isn't that crazy, you guys? $4.7 billion. And then that's just what it cost when it launched. Then they spent another... Let's see. How much did Hubble telescope repair cost? $251 million. So they're at like 5 billion. 5 billion for Hubble. 5 billion. I paid 500. Crazy. So thank you, whatever your name was. I forgot. Gordon. Thank you, Gordon. Your ego is a little, it's harming you. It's hurting you. It's hurting you. Look at what he says. That video's not out of focus. Yes, it is. It's just proof that you can improperly use any equipment if you try hard enough. So when NASA pays 5 billion and I pay 500 and I get a clearer shot, more magnified, more in focus. Oh yeah, I was going to give you guys this video in the chat, or yeah, in the chat. Copy. All right. There's the, that one's another 4K. That's the one. I think it's taken with the same camera. Let's see. It must be, because I didn't put anything in the description. So yeah, 90 views. It should probably have more. That was a recent one. That was June 14th. So you got Hubble Garbage Telescope providing us imagery like this. Are you guys serious? Look at this one. You can't even see. You can't even see Polaris AB. That's how far you have to be zoomed in to see it. Mark Jensen says Hubble doesn't exist in space. I understand that argument, but I disagree with it myself. I think that they actually launched it up into that. I don't call it space. I call it the darkness upon the face of the deep. It's the bottomless pit. It's the abyss, guys. And NASA thinks that they're exploring there. Well, they're being overwhelmed and overtaken by the spirit of exploration. That's Apollyon. And you guys, just so you know, right here, I'm working on a video that I made this morning, and it's over a half hour long, but I'll be uploading it this afternoon. Please watch it. It's some very important information that I feel. I haven't made a video like this where I'm just talking to the camera for a while, but there's some serious things that I talk about in that video. Please watch it. Let's see, what are we watching here? Okay, so yeah, I don't know what else to say, guys. NASA's got garbage imagery, and they have an ego that is sending them to hell, literally. And it's sad. It's sad to people flock behind these people like sheep. And if you look at let's go to my subscriptions. I just want to show you what's happening today in the world, because I'm sure most people aren't aware of this. There's a static fire of SN6, which is the second. Oh, they're already done. It was scrubbed, I think. But this big rocket here that SpaceX is building is, yeah. I think you guys probably saw. Let me see if I have a video of it. You guys probably saw the hop test or whatever it did. I think I got a video here. I think. Maybe not. Oh, I'm in the wrong folder. Yeah, I don't know. I wish these people didn't bow down to NASA and SpaceX like they're gods or something, because they're not. They're just fooling everybody. Oh, optics, Anthony. I was using a Sony Handycam, the 4K Handycam, and it's the model number's FDR AX-33, I think. And I'm looking that we were looking through a Dobsonian, an 8-inch Dobsonian reflector, with a 4-foot focal length through the eyepiece, through an eyepiece, or a couple different eyepieces. And all the the details on all of that is really irrelevant for this video. We're looking at, let's watch this.
3, 2, 1.
Okay, so yeah, they put this thing up in the air. Do you guys know how big this thing is? It's insanely big. It's like the size. It is like the size of a water tower or bigger. My friend that I help on his farm, he's got a silo there, and the silo is 50 feet tall, I think, and it's 20 feet wide. Well, these are about 30 feet wide, or in diameter, 30 feet in diameter. They're huge. So I don't know whatever that means, but yeah, guys, I don't know.
Full duration.
So yeah, this is all
3, 2,
means to an end.
1.
All right, guys, I'm out of here. Have a good one. Thanks for hanging out. Share it out.